Hello everyone, I am Akhil Kovaru. Today I will be presenting on one of the software weakness, that is race conditions. In this presentation, I will discuss about the race conditions and explain them with a couple of examples, and I will also discuss about the impacts these race conditions can create, and how to identify them, and how to prevent or mitigate this race condition weakness. And finally, I will discuss on a real CVE vulnerability example. Coming to the definition of race conditions. So, what actually is a race condition? The race condition occurs when a system uses a resource that can be accessed concurrently by the system itself or the others. It is an undesirable situation that occurs when a device or a system attempts to perform two or more operations at the same time, accessing the same resource. In this situation, multiple threads will be accessing the same code at a given time, which leads to erroneous program behavior. Um, some systems must execute some task in a specific sequence, but because of these multiple threads accessing the system or that particular resource, this sequence of order may not be possible. These multiple threads compete for the resource, and the resulting final state depends on who gets the resource. So it is basically a flaw that occurs because of the timing or the ordering of the events or the multiple threads. These race conditions attacks are also called the time of check to the time of use. Coming to the examples, consider the following scenario here. If assume a share system, the share system can be anything. It can be a database or a file system, or the objects in the code. So here in the database, assume that we have two different procedures, and these two procedures are executed at the same time, and also these procedures are performing, like it's using the same table for performing its operations. So, and also if one of the procedure is used for inserting the data into the table, and other procedure is used for performing the data manipulation operations, like updating the existing records in the table, or deleting the records, and also if both these procedures are performing on the same table, and just assume what happens if these both procedures run at the same time. There is a high possibility of system having logs on these procedures, because the data manipulation activities are happening at the same time on this table. So a possibility of deadlock will happen here. And another real-time example was an attack that happened on the Starbucks. Attacker exploited this race condition vulnerability and took advantage of the way funds were transferred between the gift cards. The logic for the gift cards transfer in Starbucks was, first it will check the balance on the card from which the money will be transferred. If there are sufficient funds, then it will increment the funds in the other card, and later decrement the amount from the initial card. So these were the steps that the Starbucks was following for the transfer of funds between the gift cards. So the attacker took this as his advantage, and he has sent multiple requests for this function at the same time, like thus creating a probability that events would occur simultaneously. So with these multiple threads, multiple requests the attacker was sending, so at the first step, all these multiple activities or multiple threads check for the balance in the card one, and since sufficient amounts are there, the system increments the other card with the amount requested from these multiple threads. And like this is how, the attacker has exploited the Starbucks using this vulnerability. Coming to the impacts, the first thing that can happen because of this race condition weakness is having deadlocks on the process. That is, the two systems or the processes will be waiting for one another to finish. And also hackers can take advantage of these race condition vulnerabilities to gain unauthorized access to the networks. And if a successful race condition attack will grant attackers to access secured areas of an applications, and if they get access to these applications, they can insert their own set of data into the database and can act as an administrator. And other possibilities include manipulating the API calls and making the server execute the same action multiple times. And because of this, multiple requests are sent to the server, which will lead to the denial of service attack, and thus an entire network can be brought down. So these are some of the impacts that this race condition weakness can create. The next is how to identify these race conditions. Since we know about these race conditions and the impact these race conditions can create, it is very important for us to identify these race conditions. And race conditions are very hard to detect, especially if you are not looking for them, and they are difficult to fix even if we know and are aware of their existence, and they are difficult to find through testing as well. These race conditions are the semantic problem that can arise from many possible flaws in the code. So it is best to design the code in a way that prevent these problems from the start. And another way to identify the race conditions is to run the code on a fast multiprocessor system. If we start seeing crashes that we can't reproduce on a single processor system, then we have almost certainly uncovered the race condition. And the best way to identify these race conditions vulnerabilities is through testing. And the best way to test these race condition vulnerabilities is to have access to the source code, which is nothing but applying a white box testing to the system. We can identify the race conditions through code reviewing as well. Reviewing the source code and identifying the functions in the code which can have synchronous actions, and calling those functions multiple times and checking for the likelihood of any deadlocks or system crash will help in identifying these race conditions. Deadlocks here are nothing but a set of blocked processes, each holding a resource and waiting to acquire a resource held by another process. So these are some of the ways that we can identify the race conditions vulnerability. The next is about the mitigations for these race conditions. Avoiding these race conditions not only requires some thought about our code, like what it is doing, but it also about how other parts of the systems are interacting with that code. So here are some of the ways which we can do to prevent or mitigate this weakness. The first one is thread synchronization. In this thread synchronization is nothing but we have to make sure that only one thread is executed at a time. We can do this through synchronization primitives such as critical sections of the code or the process are used to ensure that a specific part of the program can't be executed by more than one thread at the same time. We can do this by applying locks to other processes or threads that are running at the same time to enforce the critical section behavior at the thread level. The next thing we can do to prevent these race conditions is to avoid shared states. We can avoid sharing these global states whenever possible, but it is not always possible. It is not always possible in all the cases. If sharing state among the concurrent processes or routines is required, we should consider introducing a mutually exclusive mechanisms or another locking mechanisms to control access to this shared resource. And we should perform these database updates atomically. Performing the database updates atomically means that instead of doing the insertion, updates, delete, or like all the data manipulation statements at the same time, we have to perform them individually, one at a time, so that these data manipulation statements does not affect one another and create in turn create any deadlocks. The next is we can develop the parallelized code securely. The use of this parallel processing can be a major asset for any application. The parallelized code can run more quickly than any single-threaded applications, and is able to support multiple users in parallel. But at the same time, this parallelized code must be designed and implemented carefully. These are some of the ways through which we can prevent or mitigate the race condition weakness. Now let's discuss about a real CVE example which has happened because of this race condition attack. This attack was reported in 2022 with the CVE ID CVE 2022-23653. The CV access score for this vulnerability was 4.7, which is a medium level impact. And the attack was reported for a B2 command line tool, which is used for the Backblaze cloud storage device. And the Linux and the Mac releases of this command line tool for the versions below 3.2.1 were affected, and these versions can be exploited by the attackers through this race condition attack. So the vulnerability was that this command line tool saves the API keys, like whenever the user enters the API keys in a local database file. This authorization happens regardless of a valid key is entered or not. So when the keys are saved in the file and the file is created, the content of the file is readable initially and is later altered to private to the user. This happens only when the user runs B2 authorized account. So in this time gap, so like from the file changing, content of the file changing from readable to private, within this time period, if the attackers can come and attack and you through this race condition vulnerability. Coming to the impacts, if that particular directory where the file is created is readable by the local attacker, and the user did not yet run that B2 authorize account command, the attacker can race to open the file and can maintain a handle to it. Through this, the attacker will have access to the important information of the user details from that file. For the and the fix that they have made is they have updated the B2 SDK library, which is this is a client library that is used for easy access to all of the capabilities of the B2 cloud storage. So the earlier version was 1.14.0, and they have made the changes and updated that version to 1.14.1, and they have released these new changes with the command line tool version 3.2.1. Thank you everyone.